My name is Bradley Levine, and my partners are Byron and Jared. Our project is on using technology to help improve vision. So I included this quote from my research because it demonstrates how important vision is in our everyday lives. Now I will explain how vision works. Light enters through the cornea and then is focused by the lens. Finally, it hits your retina. Your retina is composed of photoreceptors, which are rods and cones. Rods are more sensitive to light. Cones are less sensitive to light and sensitive to color. Photoreceptors convert light into electrochemical signals that are sent to the brain via the optic nerve. The brain has specialized sections to handle different image processing. Information comes from the optic nerve and reaches the visual cortex. V1 gets the information first and sends it to V2. V2 acts as a relay station and sends the information to the correct area. So this is two streams that are used for different purposes. The ventral stream is for complex shape analysis and color and brightness. So this allows you to perceive those. And the dorsal stream allows you to perceive small object movement and large object movement. So like if that soccer ball there was kicked, those are the areas of your brain that would be activated the most. This is just a small number of the problems that eyes can have. Diabetic retinopathy is the #1 cause for vision loss in the United States. It is caused by a diabetic having high blood sugars constantly. The sugar builds up in the small blood vessels in the retina, causing hemorrhaging and clotting. Then there is standard nearsightedness and farsightedness, astigmatism, which is misshaping of the cornea, a cataract, which is where the proteins inside of the lens clump together and make the lens become cloudy. Then this is called rhegmatogenous retinal detachment, which is where there's a tear in the retina, allowing the fluid to flow behind it and push it away from the back of the eye. And now, color blindness affects more males than females. There's red, green, and blue, yellow. This is the result of one type of cone malfunctioning or not working at all. Complete color blindness is the result of 2 cones malfunctioning or not working at all. You need at least 2 cones out of the 3 for the brain to compare signals and see color. I'm going to give a brief overview of the technology we researched. Bionic contacts, stem cells, optogenetics, LASIK eye surgery, artificial silicon retina, and visual cortical implant. We rated LASIK eye surgery the highest because it's widely available, cost-effective, and does restore vision for a period of time. Next, we gave stem cells and optogenetics a rank of 2 because it's not as widely available, still experimental and expensive, but effective and doesn't damage surrounding tissue. And then the lowest was cortical implants because it can cause tissue damage on the cerebral cortex where it's implanted, and it's not a permanent fix and does not restore sight completely.
So the bionic contact's layout and design is made up of an array of LED pixels that are built into the lens. These pixels filter natural light, and then a microlens is placed between the eye and the pixels, enabling the user to focus on virtual images. Safety regulations. The bionic contact must remain situated on the retina, avoid generating excessive heat, and have a safe exposure. What's next in form of bionic contacts? Show all subsystems can work together. We're going to decrease the size of components and increase power harvesting capacities.
For a robotic vision system, you need vision sensors to achieve any goal. Types of vision sensors include cameras that use CCD or CMOS chips, which both consist of an array of light-sensitive pixels but transmit data in different ways, visual ranging packages, which involve at least 2 cameras for stereo vision, and object tracking packages. Goals for a robotic vision system can include visual ranging, which deals with reconstructing a scene in 3 dimensions, whole image analysis, segmentation, which breaks up an image into its features, and general object recognition. Feature extraction, an important part of image processing and analysis, involves filtering and mathematical edge detection methods to turn an image into meaningful data for a mobile robot or otherwise.
So this will be a software application to help colorblind people with color recognition. So the items required would be an optical see-through augmented reality device, like the Microsoft Hololens. It has a series of cameras on the top that take the world in a 3-dimensional view with color. Now, it would be easier to also make this application if there's an operating system on the headset, but it is also possible if they include a software development kit. And we would also need to know the type of color blindness the user has. This is all that we would need to make this simple application. So now I'm going to show the diagram that explains our idea in an ad hoc way. And I'm sort of just glossing over, the fact that we need an object recognition type of algorithm to streamline this process, but this is just the basic idea of how our application will work. So we have a completely colorblind user that picks up a red scarf but sees it in grayscale, so they don't know what color it is. Now, if the user had the HoloLens, the HoloLens has no problem seeing that the scarf is red, and if the device is programmed to know that they're completely colorblind, it could have a pop-up in the augmented view where the user is wearing the headset that has a little 3-dimensional pop-up that says, the color of the scarf is red, or have a high contrast section of text on the object itself that says what color it is. Alright, so this is the conclusion of our video, and I'll be including a link that'll show you what the Microsoft HoloLens actually can do.